Alright, today we're going to talk about our last lesson in Chapter 1. And today we're going to talk more about polygons and two-dimensional figures, okay? A polygon is a closed figure, alright? It's made up of sides, which we call segments. It has vertices, which give us the endpoint of the connection of the sides, okay? It has to have two things. It has to be a closed figure. It has to have sides that have a common endpoint that are non-collinear, and each side intersects exactly two other sides. So you can't have another segment in here or anything like that where there's three segments that intersect vertex G, okay? Only two. All right, when we call our segments with our polygons, you have concave and you have convex polygons. Convex polygon is a polygon with at least one vertices pointing out. Concave, with all vertices pointing out. Concave is a polygon that has at least one vertex pointing in. So convex, all of them vertices are pointing out. Concave with at least one vertex pointing in. All right, and then of course in our notes we're going to have it listed. A three-sided figure is a triangle, four-sided quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 is hendagon, and 12 is dodecagon. And everything after that, 13 or so on, would be 13gon. An equilateral triangle is a polygon in which all sides are congruent. An equiangular is one in which all angles are congruent. A regular polygon is a convex polygon that is both equilateral and equiangular. So I'll show you what that looks like right here. Okay? So in this example, they want us to name the polygon by the number of sides, classify it as convex or concave, and then tell if it's regular or irregular. So here there is four segments here. It is a four-sided figure, which would be a quadrilateral. Okay, it is either convex or concave. All of these are actually pointing out, so it would be a convex. And then it is irregular because all of the segments have different lengths, okay? Okay, over here in this figure over here to the right, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, so it would be a nonagon, okay? Here you've got actually two of them that are actually going in, so this would actually be a concave polygon. You only need one, so you've actually got more than one here, okay? And again, this would be an irregular figure. Okay, a regular would have this mark, but all of them would be the same number of lines. Okay, let's move on. Now we're going to talk about formulas, and these are formulas you've seen before. In a triangle, the perimeter, you're adding up all the sides together. Area is 1/2 base times height. In a square, the perimeter, you're adding all your sides together, which is also known as 4 times s. This area of a square is side squared. In a rectangle, the perimeter is 2 times the length plus 2 times the width. The area would be length times width. Over here in a circle, the perimeter is, or the circumference, which is the same idea as perimeter, is C is equal to pi times D, or you can say 2 pi r, same thing. The area is pi r squared, okay? All right, so let's go ahead and look at our first question here. It says, find the area and perimeter of this figure. All right, this is a rectangle. My area is going to be equal to length times width, and the perimeter is going to be equal to 2 times the length plus 2 times the width. All right, so you have 2 times 4.6 plus 2 times 2.3, and that's going to give you, the perimeter is 13.8, and that would be centimeters. For the area, you have 4.6 times 2.3, which would give you 10.58. and that would be centimeters squared. Okay? All right, for the circle, find the circumference and area. Circumference is equal to 2 pi r, and the area is equal to pi r squared. I'm not going to finish this one, but you would have 2 times 3.14 times your radius, which is 4. For the area, you would have 3.14 times 4 squared, and that would give you the area. Okay? Moving on. Here it says that Terry has 19 feet of tape to mark the area in her classroom where she wants to use for students to read. Which of these shapes has a perimeter or circumference that would use most of the tape? Remember, she's got 19 feet, okay? So over here on this one, a square with a length of 5 feet. The perimeter of a square, remember, is 4 times s. So 4 times 5 would be 20. She only has 19 feet, so A could not be it, all right? On B, she has a circle with a radius of 3 feet. So the circumference, which is the same idea as perimeter, would be 2 pi r, okay? So you have 2 times 3.14 times 3 feet would give us 18.84, okay? 19 is the most, so we're almost using 19 there. Let's look at C. On C, it has a right triangle with each leg length of 6 feet. So if we've got a right triangle, each leg would be 6 feet, all right? Doing Pythagorean theorem to find my hypotenuse, we have c squared is equal to a squared plus b squared. So you have h squared is equal to 6 squared plus 6 squared. H squared equals 36 plus 36. H squared gives us is equal to the square root of 72. You take the square root of it, so H would give us 8.5, okay? When I add up 6 plus 6 plus 8.5, that's going to give us 20.5. Again, we're using just 19, so C could not be our answer. All right, a rectangle with a length of 8 and a width of 3 feet. So the perimeter here would be 2 times 8 plus 2 times 3. So we would have 16 plus 6, and 16 plus 6 would give us more than 19. That would give us 23. So D would not be our answer either. So actually the only one that wouldn't go over the 19 would be B. Okay? Our last problem here for today, we've got this figure, and it says that A is located at the point 0 up 4, okay? B is located at 3 up 1. C is located at 3 down 4. 1, 2, 3. Here, I'll just leave it like this, and I'll just read it from here. 3 down 4. 1, 2, 3, 4. D is located at -3 down 4. And E is located at -3 up 1. Alright, so you've got this pentagon right here. They want to know what is the area and what is the perimeter, okay? For perimeter, remember we're adding all of our sides. I can count this side, 1, 2, 3, 4, 5. This side is 5. This one right here is 1, 2, 3, 4, 5, 6. And this side right here is also 5. So now I need to find the length of AD and AB. To do that, I need to use the distance formula. Remember, x2 minus x1 squared plus y2 minus y1 squared. All right, so A again was 0, 4, and B was 3, 1. So we have the square root of 3 minus 0 squared plus 1 minus 4 squared. 3 minus 0 is 3 squared is 9, plus -3 squared is 16. So that would give us is 9. -3 squared is 9. The square root of 18, which is approximately 4.24. Okay? All right, and then over here, same thing. AD. A, we've got 0, 4. D, we have, this is E, isn't it? I'm sorry. Point E. Point E is negative 3, 1. So we have the square root of, again, negative 3 minus 0 plus 1 minus 4. Same thing, the square root of 9 plus 9, which gives us the square root of 18, which is equal to 4.24. Okay, so when we add up all of those together, 4.24 plus 4.24 plus 5 plus 6 plus 5, our perimeter is equal to 24.48. Okay? For the area, I need to add up the area of, notice you have in this pentagon, you have a rectangle plus you have a triangle. Okay? The height right here of our triangle is going to be 3. Okay? For our height. So for area, you would have the area of the triangle plus the area of the rectangle. Base times height divided by 2 plus base times height. So you would have your base in your triangle would be 6 times 3 divided by 2, and you would add it to the area of your rectangle, which would be 5 times 6. And when you get your answer, that would give you 38.82 centimeters squared.